Good morning, children. So today we are again back with the part 2 video of the numericals from the chapter work, energy and power. So today we'll be doing 4 questions and we will sum up the numericals from the chapter work, energy and power. So the first question that I have taken today is question number 10. The question says the power of a motor is 40 kilowatt at what speed can the motor raise a load of 20,000 Newton, that is 20,000 Newton. So let's follow the rules. Rule number 1, under the heading given, we'll jot down the things which are given. 40 kilowatt. Kilowatt is the unit of power. So that is P. So P equals to 40 kilowatt. 40 kilowatt is nothing but 40 into 1000 watt. Alright, so here we get 40,000 watt. So the power here is 40,000 watt. And the next information given in the question is force, because we have the unit Newton. So 20,000 Newton. Alright, now the question tells us, okay, at what speed? So we are asked to find the speed. So we know the relation, isn't it? Rule number 2, to compare the units are in watt and Newton, both are in SI system. So we'll move to rule number 3, that is to use the best relation. And you know the relation that power equals to 4 into speed or velocity you may use. So if I make speed as the subject, I'll get speed equals to power by force. So power is 40,000 divided by force is 20,000. So the 4 zeros from the numerator and denominator gets cancelled. So I'm left with 4 by 2. 4 by 2 means 2. And the unit of speed is meter per second. So I get 2 meter per second as the solution for this question number 10. Alright. And don't follow the rule number 4, that is to write the statement. Is that okay? Alright. Now let's move to the next question. Next question that we have today is question number 12. Okay. Question number 12 says a boy weighing 350 Newton climbs up 30 steps and each 20 centimeter high in 1 minute. So in 1 minute, the boy whose weight is 350 Newton is climbing up 30 steps and each step is measuring 20 centimeter in 1 minute. Alright, so in 1 minute he is doing this work. Alright, so we are asked to find the work done by him and the power spent by him to do this work. Alright, so let's write the given information from the question. Given F equals to 350 Newton, number of steps equals to 30, then we have height of each steps is 20 centimeter. Alright, so the total height will be how much? Number of steps multiplied by height of each step, so that is 600 centimeter. So when I convert this 600 centimeter into meter, I have to divide by 100. So I will get how much? 6 meter. So 6 meter is the height. Alright. And the last information given is time. And time is how many minutes? 1 minute. 1 minute means 60 seconds. Alright. So now I'm asked to find number 1, work done. So number 1, W equals to, mgh, isn't it? The formula is mgh, or here you can write force into displacement. W equals to Fs. This is one of the formula that we know. Force here is 350 into the height. The displacement here is in terms of height, and the height is how much? 6. So when I multiply this, 6 zeros are 0, 6 5s are 30, carry over 3, 6 3s are 18, 18 plus 3, 21. So 2100 joule is the work done. So don't forget to write the statement here. Okay, this other part, that is the power part, I'm doing here, number 2. Okay, but you in your copies do it in a serial order. Number 2 is power. Power equals to W by T, the formula, isn't it? P is equals to W by T. the work done here is 2100 divided by 60. So 0 and 0 it gets cancelled. All right. So here if you cancel with 6, so 6 1s are 6, 6 3s are 18. 21 minus 18 is 30, 3 and 1 0 is here, so that makes 30. So 6 5 is 30, so I'll get 35 watt. So after this you write this statement that power equals to 35 watt. Excuse me. Okay, that was question number 12. Now let's go to the next question for today's session, that is question number 14. All right, question number 14. It says a boy of weight, okay, a boy of weight 40 kilogram force climbs up 15 steps, each 15 okay centimeter high. So here I have I have missed out writing centimeter here, so it is 15 centimeter okay high in 10 seconds, and a girl of weight 20 kilogram force does the same in 5 seconds. Compare the work done and the power developed by them. So we are asked to find the work done. We have to compare, means whenever the question says compare, your answer should or the solution should be in terms of ratio. So because we are comparing here, okay, comparing the work done by the boy with the work done by the girl. All right, so first of all let's write the given information from the question. Since there are two people here, there is a boy and a girl, so we'll make two headings here to write separately the information given for the boy and the girl. Okay, so the weight of the boy, let us assume at F1 is how much? 40 kilogram force, whereas the weight of the girl, let us denote it by F2, it is how much? 20. So 20 kilogram force. So these are the two weights given here. I hope it's understood. Clear? Now since the unit here is in kilogram force, let us convert into Newton. So here the unit used is gravitational unit of force. kgf is the gravitational unit of force, so we are converting it into Newton. So how do? We just multiply by 10. So because 1 kilogram force is 10 Newton, so I'll get 400 Newton. Similarly for the girl here, I'll multiply 20 with 10, excuse me, I'll get 200 Newton. So we got the force in the SI unit. Okay, now height. Now since they are, each of them are climbing 15 steps, both boy is also covering 15 steps, which measures each step measures 15 centimeter, and the girl is also climbing the same 15 steps. So means they are actually climbing of the same height. So I'll just denote the height with h, not h1 and h2, okay, because they are the climbing the same height. So I'll have h equals to number of steps into each step, height of each step, that is 15 centimeter. So I'm going to get 15 into 15 is 225 centimeter. So when I convert this into meter, I'll get 2.25 meter, because when I divide the 225 centimeter by 100, I'll get the height in meters. So here also for the girl also it's the same height, 2.25 meter, because they are climbing up the same height. All right, now we are asked the second information given is that the boy does this in 10 seconds, whereas the girl is doing it in 5 seconds. So the t1 for the boy is 10 seconds, and the time t2 is for the girl is 5 seconds. Now we will proceed with the question, that is work done. We have to compare the work done. All right, so number 1. So first of all we'll assume the work done. Okay, so let the work done by boy and girl be W1 and W2 respectively. All right, clear? So now by question says to compare it, isn't it? Okay, so let me have some space here. I'll just move down this question number 15, the next question in the next page so that we have the space here for question number 14, which we are doing. Okay. Now by question, it is W1 is to W2. W1 is to W2. Okay. Excuse me. Okay, then let's put the values here. W1, that is work done by boy, is given by force into displacement. So that is force, here is F1 and the displacement is height, is to the work done by the girl is force into displacement, that is F2 into the same height. Okay, so here height and height, because they are same, they gets cancelled. So I have F1 for the boy, force due to its own weight of the boy is 400 and for the girl is 200. So 200 ones are 200 twos is 400. So I get the ratio is 2:1. So here you write the statement, the work done by them is in the ratio of 2:1. So that would be the statement. All right, then let's move to question number 2. Question number 2 says power developed by them. So we have to compare the power developed by them. So we'll again assume that the power developed by them is P1 and P2. So let the power developed by them be P1 and P2, okay, respectively. So don't forget to write properly. Now by question, P1 is to P2. This is our question, isn't it? And here power is W by T, and W here is P for P1 is F1 into H by T1 is to F2 H divided by T2. So let's cancel H and H here. So I'll have, I'll have here F, that is force is 400 and the time taken by the boy to do the work is 10 seconds. Similarly, the weight of the girl is 200 Newton and the time taken for her to do the work is how much? 5 seconds. So 200 ones are 200 twos are 5 ones are 5, 5 twos are 10, 2 and 2 gets cancelled. So I'll get the ratio is 1:1. So again, don't forget to write the statement. All right, so this is how we'll do question number 14. Now we are moving to question number 15. The 15 number is the last number that we are going to do today. Okay, and I'll ask you all to do question number 16 as the assignment and you'll submit me in the evening. All right, so question number 16. Question number 16, it's a little bit lengthy, okay, but it's very, very simple. So let's read the question. A man raises a box of mass 50 kilogram, first information here is 50 kilogram, to a height of 2 meter in 20 seconds. So there's a man who is doing this work, okay, while another man, so now there is an entry of second man, another man raises the same box, means it will have same mass, okay, and same height in 50 seconds, but he is doing the work in 50 seconds. Are you getting my point? So both the first man and the second man, they are raising up the same box to the same height, but the time taken by them are different. That is the only difference here. All right, then here number A, there are two questions, A and B. Number A says compare. So when we say compare, again we are asked to find the ratio of the work done by the first man with the second man and the power developed by the first man to the second man. So in both the question number 1 and number 2 of subpart A, we are asked to find the ratio between the two person. All right, and question number 2, calculate. Now here we are asked to find calculate. So when we say calculate, we'll get such certain value here. So work done, okay, and power developed by each man. So each man, okay, we have to find how much work is done by the first person and the second person. What is the power developed by the first person and the second person? That is what we are asked to do. All right. So now question number E. So let us first write the given information from the question. Given M is equals to 50 kilogram, okay, H is equals to 2 meter, all right, and And the other information given is time. T1 is 20 seconds for the first person. T2, the time taken by the second person is 50 seconds. Okay, and the value of G is given, that is how much, 10 Newton per kilogram. So these are the information given. All right, now here we know that the two person, both the men are doing raising up the same box and to the same height, so they will be doing the same work, isn't it? So we'll write like this: work done in raising a 50 kilogram mass to a height, okay, of 2 meter against the force of gravity, that is W, will be given by the formula or the relation mgh. All right, so it's given by mgh. Hence both men will be, okay, doing, here you write doing, okay, same amount of work, that is work done by man A divided by work done by man B equals to mgh divided by mgh, that is 50 into 10 into 2 divided by 50 is the mass, 10 is the acceleration due to gravity, and height is the 2. So they gets cancelled and I will get the ratio is 1:1. So the solution for number A1 is the work okay, done by the man A and or the first person and the second person is in the ratio of 1:1. Okay, now A quiz sub part is there. We have to compare the power generated by them. Okay, so let's do power developed by them. Okay, power developed by them. So let that be P1 and P2. So I'll write P1 by P2. Okay, I'll get W by T1 divided by W by T2. Why I'm writing W here? Because they are doing the same work. So that's why both the person I'm writing W. Okay, W by T1 equals to W by T2. I'll get W by T1 into T2 by W. I'm converting this division sign into multiplication, so this gets reversed. Okay, so here W and W gets cancelled, so I'll have T2. Okay, T2 is how much? T2 is 50, okay, divided by T1 is 20. 0, 0 gets cancelled, so I'll get the ratio as 5:2. So the power, okay, developed by them is in the ratio of 5:2. So that is what the statement you have to write. All right, now number B. B, we are asked to find the work done by them, okay, by each of them. So B number 1 is work done by first man, first person, equals to mgh, that is mass is 50 here, acceleration due to gravity is 10, and the height, okay, up to which they are pressing up the box, okay, okay, all right, equals to 1000 joule. clear. Then the other one is work done by second person equals to mgh only, because they are doing the same work. So they are lifting up same box whose mass is 50 kilogram against the gravity to the same height. Okay, to the same height. So the value of g and h here will be 10 and 2 respectively. So when I multiply 50 into 10 is 500, 500 into 2 is 1000 joule. So the work done by the same person, second person, is also 1000 joule. So that's why we got the ratio, or the comparison of the work done by the two men was in 1:1 in the first solution, solution number A1. All right, so B1 is done. B2 is the power developed by them, isn't it? So power developed by first person or first man, okay, you can write anything, equals to W by T. W, let me have some space here. W by T1. W here is 1000 divided by the time taken by the first person. Okay, is how many second? It is 20 second. All right, it is how much? 20 second. So 0 gets cancelled. 2 ones are 2, 250 is 100. So I'll get 50. Now since this is power, the unit will be watt, 50 watt. All right. So the power developed by the first person is 50 watt. And now we have to find the power developed by the second person. So power developed by second person equals to W, same work, but the time is different, so we'll have T2 here. So W is 1000 divided by time, okay, taken by the second person to complete this is how many seconds? 50 seconds. All right, it's how many seconds? 50 seconds. So 0 gets cancelled. 5 ones are 5, 520 is 100. So I'll get 20 watt. So this is how we have to do. So question number 15, the one that we did just now, it's very simple question, but it's quite lengthy. Okay, so here we are asked 4 questions. Questions asked are 4. Okay, first is the comparison, second is the value for which we have to calculate and do the sum. All right, so this is it for today. I've given you the assignment. Please do it and send me in the evening. Thank you.